Hey guys, and welcome back to a new video. In this video, I will show you how you can use the Google Play in-app update API in your Android app. So this API is basically something Google offers, so your users, the users of your app, can directly update your app inside the app without going to Google Play, clicking on install, clicking on open again. So you can all do that inside of your app. And also if there's some kind of breaking change, for example, you can force your users so they need to update the app before they go on using your app. Some prerequisites for this, so what you need is actually an app in Google Play, because this API of course just only works together with Google Play. And if you want to provide a way to instantly update your app via Google Play, then you of course need to have it there. So in this video I will show you the different ways we have to let your users update the app directly inside of your app. And I will also show you how you can test all this. So here in Android Studio, I am in an already created project of mine, which is available in Google Play. That is the app I built in my CI/CD course, in which I showed how to automate the deployment to Google Play, which is why I needed to have this app live in Google Play, obviously. And for this video, I will just reuse the same app. This is a simple material calculator here I built in this course, which you can see here. And this is my Google Play console of this app. But let's first of all check how we can implement this mechanism to automatically update the app inside of the app. First of all, you want to make sure that you have this in-app update dependencies. You have access to that API in your build.gradle file. You need to make sure that you have these two dependencies. So this app update and app update KTX. So make sure to add these, synchronize your project, and then we're good to dive into coding. We can actually implement all this inside of main activity. And the first thing we need is a so-called app update manager. So this completely controls the execution of this API when you want to show this update dialog. And this is of type app update manager, which comes from this library. And we also want to have a private val update type. There are different types of updates. So we have app update type .flexible, or we have immediate. Starting with immediate, because that's pretty obvious, that is an update type that will force your users to upgrade. So they won't be able to keep using your app if they don't update before. That is very useful if you have some breaking changes, for example. So your app needs to update to adjust to some form of maybe API changes where the old version of the app would not work with anymore. Then you can force your users to upgrade just by using this immediate type. The flexible type, however, will, as the name says, leave it up to your users if they want to update. So then you as a user, you will see a dialog where it says, hey, there's a new version available. Do you want to update now? The user clicks update. And once the update is then downloaded in the background, which is also handled by the API, then the user would still need to manually restart the app. But you can tell the user, hey, the app is restarting in 5 seconds, or click this button to restart the app. But there's some more user interaction involved. And this is helpful if you have non-critical updates. So something where you only recommend to update, but you don't want to force your users. I will show you how to implement both these update types in this video. Let's keep this at immediate first of all, because that requires a little bit less setup. And then we simply want to have a function that checks for app updates. So something like this. And in this function, we first of all need to take our app update manager and refer to the app update info. That is a task, so that is something that takes a little moment, something asynchronous, in which this update manager will simply retrieve like the new version of your app if there is one, and then just check if there is an update available. We want to use this and add an on success listener to this. So this will execute the task and let us know once that was a success. Of course, in a real app, you could also handle the failure case by saying add on failure listener. I will assume this will succeed here. And then we get the info in here and we can do something with it now. First of all, to check if an update is available, we can use this info and check the update availability and compare that with update availability.update available. Then we also want to check if the update is actually supported. So if we can currently update, or let's call it allowed, is update allowed. When the update type is app update type dot flexible, we want to set that equal to info that is flexible update allowed. And if it is app update type dot immediate, we set it to is immediate update allowed, and else just false. And if both that is the case, so if there is an update available And it's also loud. And then we want to start the update flow to show the UI to the user. So I want to say info start, or how is it called? Is it the app update? Yeah, it's app update manager, start update flow for result. Here we need to pass in our update info. We need to pass in the update type. We need to pass in the activity, which is this. And we need to pass in a request code, since this will trigger the onActivity result callback, where we can then check if updating was successful or not. So here we can just pass anything as long as you use the same code in the callback. And just to show you how you could check that, you would need to override onActivity result. This is a deprecated function, but currently this update API only supports this, I think, because it doesn't support these activity result launches yet. So in here you would need to check if the request code of the incoming result is whatever you chose for that. And then you can check if the result code is not equal to result OK. That means something went wrong, and you could log that here. Something went wrong updating or so. And then all you need to do is to go over to onCreate and call check for app updates, or whenever you want to do that. Maybe you can also show a button to the user to let them check for updates manually. That would of course only make sense if it's a flexible update. Oh, one more thing is we need to create our app update manager, of course. That is equal to app update manager factory.create, and we can pass in our application context. And I think before I show you how to test this, it makes sense to also show you how we can handle flexible updates, because that is a bit different. Since here we also need to handle the download progress. So then the user will actually get a notification that the app is downloading. And after it has been downloaded, we need to observe that state. And then we need to tell the user, hey, the app has been, or the update has been downloaded. And now it's up to you to relaunch the app, or we can also do that programmatically. But yeah, we have to at least call that function. And for our check for updates function, nothing will actually change. This already handles flexible updates here. But something we should do, at least according to the docs, is we should override the onResume function. And then we should say app update manager, app update info, and we want to add an onSuccess listener to that, where we get the info again. So whenever we get back to the app, if it's in the background maybe. And here we want to check if the info that update availability is equal to update availability that developer triggered update in progress. And if that's the case, we simply execute this same code to start the flow for result again. So according to the Android docs, it can happen that the update could be kind of stalled in this state when an update is triggered by the developer. And with this onResume check, you just want to make sure that if the user, or if there is currently an update downloading and the user minimizes your app and then gets back, that the user is not kind of stuck in that state. And this, by the way, can only happen for immediate updates. So yeah, let's just add a check here. If update type is app update type immediate, then we do this. And it's of course also fully up to you what your app should do if a specific user declines the update. Then it's of course completely individual for your app to handle that scenario, and maybe let the user know, hey, without this update, this app won't work the way you're used to anymore. Similarly, as you would handle it if the user would maybe decline some form of permission or so. But getting back to flexible updates, as I said, in that case, the app, or the new app version will be downloaded in the background by seeing a notification, and we need to keep track of the download process. And the way we do this is with a so-called install state updated listener, which is exactly the same, called exactly the same. Here we get updates to this install state. You can also use this function to check if the state bytes downloaded, for example, and total bytes to download. This can be used to determine or to find out how large the update is if you want to show some kind of progress UI directly inside of your app, apart from the notification. But what we will use here is, to keep this simple, we want to check if the state install status is install status that downloaded. And here you can also check if the download was cancelled, if it is currently downloading, if it's failed installing. So depending on what you want to do in your app in these different states, this is the place where you need to handle that. We only care about downloaded here. And in our case, I just want to show a toast with application context. And we just say update or download successful restarting app in 5 seconds. Something like this to let the user know what happens. Toast that link long, that show. And then we want to restart the app after 5 seconds. For that we can delay a coroutine in lifecycle scope. So lifecycle scope.launch, and we say delay for 5 seconds. Import seconds, and then after that, we want to call app update manager.complete update. That's also a task that could take a little moment. We don't need to observe anything there if it was successful or not. But if you want that, and if you want to let the user know if completing the update succeeded or not, then this is the place to do it. And then we want to scroll up. Right after we initialize our app update manager, we now want to check if the update type is app update type.flexible. And in that case, we want to register our just created listener. So I'm going to say app update manager, register listener, and the listener is our install state updated listener. We also should unregister this listener again in onDestroy. So let's just scroll down to the completely bottom, override onDestroy. And here we want to say if update type is app update type.flexible, then app update manager, unregister listener, install state updated listener. So far, so good. That is at least the code part of implementing this API in the simplest form we know. But you will notice that if you launch this directly on your device like this, if we take a look here, then, well, the app will work obviously, but nothing will happen. We're not prompted to see an update. And the reason is that we need to opt into some kind of special form of testing this, because this interacts directly with Google Play. And one way we can test this is called internal app sharing. For that, you need to go to your Google Play console, scroll down to internal app sharing. And if you open this the first time, you will need to accept some terms. But after that, this is basically a way where you can upload, debug and test APKs to Google Play without making a specific release. And for these, Google Play will then generate a URL where your testers can download that APK, and it is considered as a Google Play app in the end. So this API will work in that case. And as soon as you put your app to production on the production track in Google Play, then this API will also directly switch to the production mode, and real updates will of course be downloaded in that case. So make sure to click on this little URL here to get to this detail page of internal app sharing. And this is now the window where we can drag in our debug APK. I mean, not debug, we will actually build a release one here, but I mean our testing APK. And you can see I tested this quite a lot in the past with different versions. So all these are releases here in internal app sharing, and I will show you how we can now do this. Let's go back to Render Studio. Let's switch back to immediate update type. Let's test that first. And before we go on, actually, there seems to be a quota for these in-app updates, even if you use this internal app sharing. Because occasionally, if I opened my app way too often, then I stopped seeing these update dialogues. But then if I open it the next day or so, it started appearing again. So I think there might be some kind of quota in that API. So usually if you implement it like this here, then it will work fine. But if you try this out too often, it could be that nothing will show up for you. That does not mean that it doesn't work. So let's make sure to switch back to immediate. And then we want to build the release version of our app. For that, go to build and generate a signed bundle APK. I'm not sure if this is necessary that it's a signed bundle, but I've read that it's recommended to use the same signing key as you do for the app that is in Google Play. So the same signing key for the internal app sharing version. So let's do that. We want to create an Android app bundle. Next, just pass in your keys here and passwords. Click next. We'll build the release build. I also read that this is recommended for internal app sharing. Then click create. Wait a little moment until Gradle finished building this. And there we go. This little pop-up will show up. You can click locate to open this in your Finder. Oops, I don't want to do this right here. And then we can open Chrome again and simply drag in this app release here in our little window. This will now upload the bundle. And after that, we will be prompted to choose a version for this. I will just choose 1.0.29 here because that's just the next one. You can choose 1.0.1. If you don't have a version here yet, then click upload. And then you can see it appears in this list here. And with this button, you can copy the link. However, right now we could still not test this because we will first of all need to install this version on our phone to have this behavior that it actually knows that we have and use this update API. But that still doesn't mean that it thinks this is an update, because we will only have this single version. So we will need to push another release to our internal app sharing, which should then be treated by the previous release as an available update. And for that, we will need to go to build.gradle app and scroll up to this version code. This needs to increase. So this is how Google Play actually knows if there is an update. If this version code is a higher version code than the APK you have installed, then it knows there is an update available. We can then click sync now, go to build again, generate another signed bundle, next, release and create, and then upload that next bundle into the internal app sharing again. So here, locate, go to Chrome, drag that in here, choose another version, click upload. Okay, now we have these two versions in this internal app sharing. Now what we need to do is we need to install the first one on our real device where we are logged in with the same account in Google Play. We are logged in this Play console. So we need to install this. And then we just need to add this version as kind of a reference to that device, so it knows there is a new version in internal app sharing, but not install that. If we then open the first one, we should be able to see the in-app update dialog. But before we do this, you need to go to your Google Play and enable this internal app sharing. For that, you need to go to your profile, so your settings, your menu, whatever, click on settings, about. And here, this is similar to developer options in Android. You need to tap on this Play Store version, I think 7 times. It already tells me I am already a developer, but for you, you need to do that to unlock kind of a secret setting here, which is under General, then Developer Options, and Internal App Sharing. This needs to be turned on in order for this to work. Once you have that, make sure to copy the link of your first release, so this one here, and open that in the browser of your Android device. I will do that and then I will see you back. So here I am, I opened this link, and if we now click open in Play Store app, we will get to this screen. And it might be that I did not increase the version code since I already had a version of this installed, that it does not tell me that I can update here, but let's uninstall this patcher. For you, this probably won't show, but we want to make sure that we install this, that we have this version from internal app sharing active here. So there we go. If we open this, probably nothing will happen. Right, nothing happens, the app opens, but we still, first of all, need to add this new link here of the latest release with the highest version code into our internal app sharing. So now, copy this link and open that in your browser in your Android device. So here I am, I opened the next link, and if we now open that in Google Play Store app, then you can see now it actually tells us there is an update. Don't click this now because we want to open the previous app to check if it is able to automatically update. But for that, you at least need to get to this screen once so the device knows there is a next version. And I really hope this will work now. Let's open this Material Calculator app now with the previous version. And yes, there it is. There is the update dialog. It says to use this app, download the latest version. And here you can see the user could cancel this. Then it's up to you how you handle this. If you let the user still use your app, or tell them, hey, you just need to update the app, otherwise it won't work anymore. But if we click update, however, then there's an immediate update. So it will directly update here inside of the app in form of a dialog. It will install this. And then after a little moment, it will just show the app, it will directly relaunch it, and we have the update installed. And hopefully I'm also able to show you the flexible update here. If my quota is not used at this point, maybe for some reason it might not show. That happened quite often to me, but the code itself should work. So what I will do is I will create another release here where I change this to flexible. And then after that, I will have to make another release because the flexible update type is only applied for the next release, which I have to update to first. And then I need to make another release so the flexible release knows there is a new update. So once I did that, I will see you back. There we go. So what I did is I pushed 2 more APKs here into my internal app sharing. On the one hand, version number 31, which is currently installed on my device, and version number 32, which is not installed, but I added the link in on my device again. And I could click update, but we don't do that. We want to launch the app as it is, and I hope that it actually shows the flexible dialog. Let's see. Yes, it does show that. Very cool. This is now a different dialog. And with this flexible approach, we just flexibly download this APK and then we can decide when to install this. We do this 5 seconds after the download has been finished. So if we now click update, then we will see the download progress as a notification. And once that's happened, we see the toast restarting app in 5 seconds. And after 5 seconds, it will install that and our app will reboot. And there we go, our update is installed and that seems to be working perfectly fine. So I hope you enjoyed this video. If you did, then you'll definitely also enjoy my CI/CD course, in which I show you how you can automate the deployment to Google Play. So to, in the end, automate as much as you can from running your app's test cases, from distributing it to your testers, and to, of course, uploading it to Google Play to the right track. This synergizes really well with all these APIs, like the Review API and this in-app update API. So if that sounds cool to you, check the first link in this video's description to check out the course. And I wish you a very amazing rest of the week, and I'll see you back in the next video. Bye-bye.